Hi guys, today we're going to be looking at distance time graphs, okay? So first of all, Rebecca rollerbladed from her home to the playground. She then rested in the playground for some time, she then rollerbladed home. Here's the distance time graph of Rebecca's journey. So question A says, how long did it take Rebecca to rollerblade from her home to the playground? So this is her home, and this is the playground. So I can say that here is, these are going up every 2 squares with 1, so 11:04 until 10 past 11. So I'm going to say that was 6 minutes. Okay. How long did Rebecca spend resting in the park? Well, that was from 10 past 11 until 11:15 because it's a flat line, so that's going to be 5 minutes. And then, was Rebecca's speed travelling home faster or slower than travelling to the park? And explain your answer. Okay, well, I'm going to say that this line is the steepest. So we know that a steeper line is a quicker line. So travelling to the park was quicker for that reason. Okay, here we have 6 graphs. It's just coincidental that it's Mr. Jones. I did not make it this way. And they're all telling 6 different stories. So let's have a look at the first one here. Mr. Jones leaves work and travels home at a steady speed. Okay, so here he's at work and he travels home. Home is always like distance of 0. So that must be graph D. Next one, Mr. Jones leaves home and travels to work at a steady speed. Okay, so home is obviously here. And he travels to work at a steady speed, so that's graph A. Next one, unlikely, Mr. Jones stays at work. So that's just a flat line, he's at work and he's just staying there all day. C. Next one, Mr. Jones travelled to work, stays there for some time and then returns home. Well, that'll be graph B. He goes to work, he stays there and then he comes home. Which means the last one must be E, but let's just check it. Mr. Jones leaves home, he travels to work, stopping at the shop along the way. Okay, so he's at home, he leaves, this must be the shop, and then he goes and he finishes up at work. So that's right, that's E. Next one. Here's a distance time graph for a train journey. Calculate the speed of the train on the last section of the journey from 70 to 90 minutes. So I'm going to zoom in here, okay? So from here to here. So from 70 to 100 minutes, sorry. From 70 to 100 minutes, well, that's 30 minutes. And the distance that he travels is 20 miles. Well, if we think of speed as the distance that you travel in 1 hour, if he can travel 20 miles in half an hour, in 1 hour he would travel 40 miles. Which means he has travelled 40 miles per hour. Circle the part of the journey that the train travels the fastest. Well, we know that a steep line is a faster line, so this must be the fastest. I'll explain your answer. Well, we're just going to say because it's steeper. And lastly, Roy visits his aunt and then returned home. The distance time graph shows the information about Roy's journey. Write down the time that Roy started the journey. Well, let's see, these are going up in 10, 20, 30, 40, 50, 60. So that's every 10 minutes. So 10 past 2. Remember about PM. At 2:50, Roy stopped for rest. That's up here. How many minutes was the rest? 10, 20. So 20 minutes. He stayed at his aunt for 30 minutes and then returned home. Work out Roy's average speed on the journey home. So let's see. So this is whenever he left. He left at 3:50. And then he got home at 5. What I'm actually going to do is I'm going to look at it like this. So if you look at the black pen, at 4 o'clock, he was at 60, and at 5 he was at 0, so in 1 hour he travelled 60 kilometres. So that means he travelled 60 kilometres per hour. Work out the total distance travelled by Roy. Okay, well if we look at this, he starts off at home, which is 0, he travels all the way up to 70, and then he comes back home again. So he travels 70 kilometres there and 70 kilometres back. So in total he travels 140 kilometres. Okay, so there's distance time graphs for you. Okay, I'll put a wee worksheet for you as well. See you now.